The compound operation level in morphology consists of two functions. One is opening. We do opening when we want to remove small objects, but we want to preserve the same shape and size. To do so, we combine two operations, erosion and dilation. The effect is similar to erosion, but with the less destruction of the image. The illustration best shown is here. We can see the input image here, and then we apply erosion when we get a smaller image, and then we apply dilation to expand the image. So this is opening performed. Then there is a closing, which we use when we want to fill in the holes but preserve the original size and shape. To do so, we are mixing dilation with erosion. Not mixing, but do it step by step like this. This is our input image. We apply dilation, so we expand all the bright spots on the image, and then we use erosion. And this is the resulting image. Hello, my name is Jana, and I'm continuing the lessons of image processing, and now I'm going to talk about morphology. So morphology is another set of operations we apply to input images to solve mostly three problems, and we apply it to grayscale and binary images. So those three problems we can solve with morphology are the follows. As you can see in the A image, we can remove small objects, the noise. In the B image, you can see that we can fill in the holes of the objects of the image. And C illustrates that we can isolate objects in the image from each other. Morphology operates like neighborhood processing, applying a kernel to each of the input pixel. And the kernel is called the structuring element. And morphology consists of three levels of operations. So level 1 is we apply a kernel and we either hit or fit. What that means I will explain in a second. And following those operations, we can see that we either delete the image or erode. If we combine those two operations, we can have the compound operations. So dilation. Dilation is when we make the image bigger. Let's say we have the background black and the image is white, and then we apply the hit operation on the input image. Hit means that if the value of the if the value of the output pixel is the max value of all pixels in the input pixels neighborhood. In binary, it means if any pixels input picture's pixel value is 1, which is the highest, then the output image's pixel will be 1. We can see it here illustrated. This is the input image pixel array, let's say, and this is the structuring element. When we apply it to the input, and if there is at least 1 1 in the input image, the output will be 1. And when there is only zeros, none of the ones, then the output is 0, and so on. And as we can see, the dark patch is being reduced, meaning that the white main object is being expanded. It is seen on this illustration. So the bigger structuring element size, the more dilated bright spots on the image are. Erosion is the opposite of dilation. So erosion is when the value of the output pixel is the minimum value of all pixels in the input pixels neighborhood. In binary, if any pixel's value is 0, the output pixel will be set to 0 as well. And it can be shown by this matrix as we had previously, except that when we apply to the first input pixel, and there is at least one 0, here are 2 we can see, then it's going to be 0. And we get 1 only if there's all the 1s within the kernel structuring element, right? So we get only 1. So erosion means that the object gets smaller. It's best illustrated on this picture. So it also depends on the size of the kernel applied. So those are hit and fit operations.